This video, I'm going to show you how to go through the problem-solving process. As an instructor, how would I teach my students? So the first step is, and boy, this is a long word problem, right? Welcome to chemistry. So first thing I like to do is go straight to what is the question? Find the specific heat of the metal. All right, well, specific heat has a certain variable, Cp, and then I'm going to say the metal. And I like to write equals question mark. In case I get distracted, that's going to tell me what I'm looking for. So first of all, skip the extraneous information that we may or may not use and go straight to the question. Then we're going to look at what's given in the problem and see if we can relate these things to what I'm looking for. So remember, I'm looking for the specific heat of the metal. All right, so what's given in the problem? And so this one is interesting. I've got some water here, and I'm just going to draw a little picture. This might help. I've got water, and it's at 21 degrees C, and we're going to drop some hot metal in here, and the metal is going to cause the temperature to go up to 31 degrees C. So there's a little thermometer in this metal. Now, this is a calorimeter, and there's a calorimeter equation that you may know. And it is this, Q equals M Cp delta T. And I feel like I'm going to use this to solve this problem. Well, there are two parts of this. I've got the metal, and then I've got the water. And so what I need to know is this very thing right here. The heat that the metal loses is equal to the heat that the water gains. I'll use W for water. Okay, so if the temperature of the water goes up, where did the heat come from? It is the heat that the metal gave up. So basically, I am going to use this Q equation for the metal and for the water and set them equal to each other. All right, so let's see what is given. Well, I've got mass here, mass of the metal. I've got the initial temperature of the metal. And then we've got the water, we've got the mass, we've got the initial temperature of the water. And then what is this temperature right here? That's the final temperature of both the metal and the water, right? They're going to come to the same temperature. And so I think we're going to be able to solve this problem by setting these two things equal. So the other thing you would need to know here would be the conservation of energy. Right? If energy can be transferred, it's not created or destroyed. All right, so the next step would be to start with the formula. So I'm going to say the Q of the metal is equal to the Q, I'm sorry, not negative, but the Q of the water. All right, let's write the Q equation for the metal. So the mass of the metal times the specific heat of the metal times the delta T of the metal, right? And that's T final minus T initial. Same thing for the water side. Mass of the water. Hey, let me switch colors here. Mass of the water, specific heat of the water, T final minus T initial of the water. Okay, on the water, I think I have everything. 112 grams. Specific heat of water is probably given for you. This is a constant, 4.1 joules per gram degrees C. Delta T for the water, we're going to end up at 31 and we started at 21 degrees C. Look, I have everything on the water side, so I could calculate a number here. Now let's go over to the metal side. The mass of the metal was 25 grams. Specific heat is what I'm looking for. Don't call that X, right? If there's a real variable, Cp, then let's use it, right? Don't confuse yourself with an X. Make sure you hang on to that variable. And then the temperature change of the the metal was, we started off at 100 and we ended up at 31 degrees C. Okay, so that's a negative temperature change. And then notice I have a negative out here. So we'll end up, the sign will work out. So when we solve all of this, this variable is going to fall out. And this is how we solve for the specific heat of the metal. And if you watch your units, right, the units are going to come out in joules per gram degrees C. And that's going to be 2.7 joules per gram degrees C. Okay? And so show your steps. Show the variables, and then plug in your numbers with units. And then the last step would be to solve. Now, the next question would be, is your answer reasonable? Okay, did our specific heat come out with the right units? Is it, it's somewhat close to the specific heat of water. So water was 4.18. Okay, and then for this metal, we got 2.7. It's reasonable. Okay, the units worked out. And so I think we're good. So that is how we solve the problem. One of the best things that you can do is just identify the information given, relate it back to an equation or something that you know. The way to solve the problem may not necessarily be using an equation. It could be explain why. It could be compare two factors. Okay, and so the the second step is, what do I know? Okay, what is a relationship? Maybe it's an equation like it was in this case. Maybe it's a law. Maybe it's a graph. Maybe you're looking at numbers on a graph and comparing something. So the last step would be, make sure you answered the question. Sometimes you solve for something, or you say the word yes or no, or higher, lower, but maybe the question was explain. So when you're all done, go back and check, what was that question? Did I answer it completely? I hope this helps you in your problem solving.